Let's take a quick look at the overview of how the OTDR is set up and run. So if we go into the OTDR setup screen, we have the configuration options for the OTDR, which adjusts the acquisition settings. So this lets us choose whether we have a launch or tail cable selected. We choose our wavelength. We can choose both wavelengths or one wavelength for each mode. The refractive index and end of fiber, we can get into the details of this in a later video. The configuration mode, which is going to be auto or manual. So right now we're choosing to acquire the trace using the manual settings. If we use auto, we notice that we can't go forward past this page. With manual turned on, we can move forward to our averaging time. We'll leave it on 15 seconds right now, which is fine for the fiber that's connected. This fiber is about 500 meters in length. You might need to go longer depending on the length of the fiber and the amount of loss in the cabling. The event sensitivity, we will go in further details later, but right now we'll leave it on medium, which means it will collect most events, but will ignore noise in the fiber. The range of the cable, this should be set to about twice the actual fiber range. So again, the fiber that we're testing here is a little over 500 meters. So we'll set this range scale to 1 kilometer. That's a good rule of thumb. Pulse width, we'll go with 30 nanoseconds. We can go with 5 nanoseconds or 10 nanoseconds to get a shorter pulse and a shorter dead zone. But with multi-mode fiber, with this type that we're testing, 30 nanoseconds will give us enough power to measure out to the end of the 600 meters. We'll look at the limit configuration later, but right now let's just run a test and see what that looks like. So this gives us a confirmation screen, so we're happy with our settings, and it'll start scanning. So each time it's testing here, it's doing thousands of tests in this 15-second period and averaging all that information together to average out the noise. And so the longer you run the test, the more averages you get and the more noise is averaged out of the trace. And that gives you a cleaner picture and helps the acquisition engine acquire and identify the events more easily. So right now it's showing us a schematic view where we have symbology indicating the events of the fiber. So we can touch on one of those and it will show us what type of event it is, where it is, and how much loss it has. So here, this particular splice is shown in red because it exceeds the loss budget for the limit that we have selected. It's a loss of 1.5 dB. The events shown in blue here are passing. So again, it shows the type, where it is, how much loss it is, and if it's a connector, how much reflection it has. Pushing this button here will let us see the trace view. And so I'm currently zoomed in because it remembers my zoom headings from my previous testing. So we'll go ahead and just set this and zoom it back out. So here's a view of our whole trace. Now I'm going to go ahead and choose my A cursor and set it to here. And we see here it's showing 0 meters at this first event instead of 0 meters back here. And that's because I had a launch cable selected. So basically what it's doing is it's ignoring the first 150 meters and saying 0 meters or the start of my fiber is right here where this first connector is. So that lets me measure this first connection and ignore the length and the loss of the launch cable up to that point. I can choose to toggle between my A and my B cursor. The active cursor is solid. And here I can choose between the measurement types, and it's showing me a blue and a red number. So it gives me the loss for each of those cursors. So if I put the A cursor here on that splice, it's showing me a loss of about 1 dB. And if I move cursor B to this connector here, it's showing me a loss of about 0.3 dB for that connection. So that's a quick overview of how the trace screen looks. If we go up to the next screen, we have the event table, and this shows us the events with a pass-fail indication for each one, the type of event, where it is, the loss. This gray line here at the bottom is the total link, so it tells us the total loss of the whole link, which in this case is 3.8 dB for the whole link, including all the connectors and fiber. with a reflection of 15.7 dB, or that's our ORL. We can go through each event by either tapping the event on the screen here, tapping the icon for it, or by tapping on the trace. And that will, or not the trace, but the line in the event table to focus on that event. And then for each of those events, we get a zoomed in view of the trace for that particular event. So those are our three views on the OTDR screen. And then when I'm ready to save it, I can push the save icon, choose which project that I want to save it to, and give it a name. And I'll just put a 2 after that, and it will save with that file name.